Hey there, I'm Potch. I am a web developer with Mozilla, and I work on the Firefox Marketplace. And I am speaking to you today about how to build a FirefoxOS Marketplace app. And sort of to answer the question, what is a FirefoxOS app anyway? A FirefoxOS app is really a web app and really targeted toward a mobile platform. But I'm going to try to answer questions and clarify some of the confusion around what that means and how best to build one. So what makes a FirefoxOS app is the manifest. The manifest is a JSON file that contains information about your app, the name, icon, etc. It's served with a special MIME type to indicate to the browser that it's more than just a file. It actually is representing an app. But really, it's just a very simple file that enhances an existing piece of web content with app properties. This is an example of a manifest right here. This is sort of a silly tic-tac-toe app, but you can see there's a name, a description. We're talking about who the developer is and how to start up the app, and some other pieces of information such as icons for listing in the marketplace and showing on the home screen of the phone. This alone can transform any web page into an app, but to make a good FirefoxOS web app may take a little bit more than that. There are a couple of different kinds of FirefoxOS apps. The primary one is, or the most easy one, is the hosted app. The hosted app is where you take an existing website, hopefully targeted toward a mobile audience, and you give it an app manifest, and then just like that, it is now an app. It's an app based on an existing site, and that's really isn't anything else to it. The nice part about these is it's really, really easy. If you have a working website, then you've built a working Firefox app. This is great if you're someone who isn't so comfortable with JavaScript, CSS, HTML, because you're really building a Rails or a Django-powered site that is all very database heavy, and you're sort of not comfortable with some of the more HTML5, AJAX kind of stuff. This is all well and good, but there are kind of a lot of problems with this approach. It's not that easy. For instance, when you're running as an app, you actually don't have browser Chrome. So if you're relying on something like the back button, then you're actually going to be in trouble because there is no back button. You're going to have to modify your app to provide a way to navigate through the history of that app. Additionally, you have a lot of performance woes when you're technically a hosted app because everything the app needs to do is online. That means that you're going to have to go online for every single request, for every single action. If a user clicks a link, we're going to have to make a request to a remote server, figure out what you meant, and then come back. That's slow, and it's a bandwidth hog. If you're not making AJAX-style requests, you're going to be sucking down bytes that you don't need and are already on the device for every single user action. And in our launch markets, bandwidth equals money. Bandwidth is at a premium. Data in cell service is not as widespread as you think, and users are not always with connectivity in the same way that they are around here. Additionally, a hosted app has little to no offline support. Since there's a remote server providing all of the data, if you don't have a network connection, you don't have an app. You get what I refer to as the gray screen of sadness, which is the splash screen that we have and we show before the server has to respond with any information, because we don't even have a splash. We have just the name of your app. Additionally, the browser cache can help here. If you've loaded your app before and you have already downloaded some assets, then if they're still in the browser cache, then they will load up in your app. But it's very unreliable, and as anyone who's viewed a couple YouTube videos will know, watching a couple videos will push the existing data out of your cache really easily. Sort of the slur for these kind of apps that people like to pitch around is the glorified bookmark, meaning these apps are really just bookmarks. They don't provide any additional app-like functionality beyond what exists on a normal web page. This makes me sad. I like to liken these kind of apps to the SUV. They're big. They're really capable. They drive really well. If you get in an accident, they're really durable. But they're kind of a resource hog. You know, they're sort of not outmoded, but they're just not built for a more tight economy of data and higher prices of resource usage. So while these are perfectly legitimate apps, they're not really going to be the best FirefoxOS apps, particularly in low bandwidth situations. The second type of app is the packaged app. And at its heart, all this really is a zip file of static resources, including that app manifest file. To create a packaged app, you simply build a site using HTML, CSS, and JavaScript. If you've ever built a static web page back to the days of GeoCities, then you've technically built a packaged app. You just need to write a manifest, and you're off to the races. This has a ton of benefits. The biggest one is there's no hosting required. If you give us a package app, we can then deliver it to your user without having you point you to a server, which means lots of users, no additional hosting requirements. If you're an HTML, CSS, JS nerd, this is the app for you, because you don't have to worry about hosting stuff and configuring databases and all these sort of DevOpsy sort of things that are maybe not your forte. There's a fantastic first run experience for these apps too. Because the full zip file is downloaded when the user installs the app, the first time they press the icon, all the resources and media are there for your app to run. That means that even if the user is offline when they launch your app, they're still going to have the full app experience. This is awesome. It goes without saying that performance, because everything is offline, is really high. There's no network request for these resources. So when the user launches the app, everything is fetched at the speed at which it comes off the file system. There's no latency. It's a very, very nice experience and lends itself really well for media-rich but connectivity-low apps, such as games. No connection, no problem. Additionally, if you are a packaged app, you have access to some extra APIs that other apps and hosted apps don't have, such as socket connections, possibly even things as advanced as the camera and text messaging and contacts. The nice thing about these apps is that they feel like native. They are quick, responsive, the user interacts, and something responds immediately. It's a really nice experience, and it's what we really want to provide people. That said, they're not the be-all, end-all of apps. They're monolithically updated. Because we're delivering one single file over the network, if you need to change any resource inside of that package, you have to give us a whole new file, which means when there are updates, they're going to be relatively resource heavy depending on how big your app is. Communication with an external server is harder. Even if you build a game, sometimes you want to do maybe some tweeting or sharing with friends or a leaderboard, things that require a network connection. Well, because you don't have a network connection, you're going to have to try to talk to a server. And because you're not a web page, you can't actually make an AJAX request, which means you're going to have to fall back to other strategies such as JSON-P and setting up CORS headers, things that are actually not that easy, and all of a sudden go back into our sort of nasty server environment. Also, those great APIs I talked about, well, they have a dark side. Because you have more power and you can do more things on the user's phone, that means that we have a much stricter review process for these apps. You have access to do more damage, and so we really need to scrutinize the things that you're doing with your app. It means review may take longer, and we may ask you to change things. And lastly, a folder full of files isn't really a web app. It's not really webby. It doesn't have a URL. Links don't work necessarily the way you would expect. It just doesn't feel like it's taking advantage of the stuff that makes the web the web. And right now, more importantly, packaged apps are only running where the idea of a packaged app is supported. If you're familiar with the Chrome Web Store, you can run their apps in Chrome. If you build one of our packaged apps, it's going to run on FirefoxOS and Firefox for Android soon. Other platforms may come later, but in the short term, you're really sort of without that sort of everywhere experience that is the promise of the HTML5 app. I liken these to a bullet train. It's sleek, it's fast, it's powerful. But if you need to go somewhere where there aren't tracks, you're out of luck. There is, however, a third way. And it's not really that different from the first way. It's technically a hosted app, but it has properties of a packaged app. I kind of refer to it as the hybrid app, but it really is just a modern HTML5 web app. Using technologies that are already out there on the web, we can create an experience that starts up fast, feels native, and still contains all the goodness and the things that we love so much about building web apps. The pros of this approach is that it still has that great first run experience because we can provide a list of resources to download when the user installs the app. By downloading those resources up front, we can, even though technically we still need to go online for some things, we can make sure that when the user starts the app, they get something. It's still a web app, which means AJAX is easier. Links work more like expected. Dynamic content, powered by possibly a database, way easier using existing technology. Performance. By caching some files right up front before the user even launches the app, we're reducing network requests for those static resources, meaning we get that same packaged app level of responsiveness. There's a graceful offline experience via the same mechanism. Via the same mechanism yet again, it's also bandwidth friendly. You can see there's a lot of benefits here. And, like I said, it's still a website, which means because it has a URL, it's available wherever fine web apps are served. You can go check it out in another browser and see how it looks. You may have to make some adjustments, but at the very least, you're not spending effort building for an individual silo. And a well-built web app can still feel like native. And that, of course, with some caveats, is really what we want here. The cons is these apps are more than your traditional server-driven apps. They still require a lot of front-end knowledge. They acknowledge knowledge of, for this to work properly, you're going to need to know about new and emerging web technology, some of which is not fully implemented in all browsers. To make this stuff work is going to require sort of exposing yourself to the state-of-the-art of web dev, which might be more than you've signed up for. Additionally, because these are hosted apps and not packaged apps, all those APIs, well, they're not really available to you anymore. So unless you really feel the need to use camera or stuff like that, you're going to be out of luck. However, some APIs are available. Geolocation. We're going to have the ability to get camera information pretty soon using the standardized WebRTC stuff. And as the APIs that we're building for Firefox OS, which have all been submitted to the standards process, are agreed upon by more browsers, some of these technologies and abilities may show up in browsers outside of just your platform. So even though today there are fewer APIs, more are coming every day. And like I said, because these are very client heavy, and because you need to do a lot of intelligence on the device, and because the device is based on a web browser, most of the code will be in JavaScript. If you're not comfortable with JavaScript, these are going to be a much more difficult app to write. That said, you should find your friendly front-end developer and ask him for some tips. The secret ingredients to these apps are that they are designed for mobile. They are using the newest CSS features, media queries, responsive design, and they are really sort of adapting to the screen that they are given. That could be a small screen or a large screen, or a combination tablet phone that's 5 inches and you have to carry in a special pocket. They are also touch-friendly. A good Firefox OS web app knows the difference between a finger and a mouse cursor and knows that a finger needs a bigger click target and acts a little bit differently. And in fact, for certain things, uses a completely different set of events. Meaning, if you want your app to really feel responsive, you're going to need to actually optimize it for touch and detect when touch is available. We're going to store those static resources locally using a technology that's introduced in part of HTML5 and has been available in modern web browsers for a while, called the HTML5 offline cache. I'll speak about that a little bit more in just a moment. We're going to handle connectivity loss gracefully in these apps, meaning we're going to try to detect when the user has a network connection, and we're going to do the right thing. If we know the user isn't online, then there's no sense making requests for more data. Additionally, because we don't want to download lots of data while we're using these apps, we're going to fetch only what we need asynchronously and not load everything from scratch. And lastly, it's a web app. The web depends on URLs. Your app should depend on URLs. Your app should have deep linking support, meaning if a user wants to share a specific piece of content, they can arrive at the app and get to where they're going. URLs are shareable, and URLs are really the strongest way that we have to sort of take advantage over apps. So really what I've described to you is a really well mobile optimized single-page web app. Single-page web apps have been around for a long time, ever since the Web 2.0 era, really. There's some really common examples that you can see. There's Gmail and Facebook and Twitter, and of course, the Firefox Marketplace, which we're working on right now. All of these things make a single main request to download their resources, and from then on, user actions are done asynchronously, replacing portions of the page. That said, they may not look like they are these style apps, but they actually are. And some of those technologies they use to bridge the gap we're going to be discussing right now. The first one is Appcache, the HTML5 offline application cache. This is a standard that came out along with the HTML5 standard. It defines mechanisms for which you can define a list of resources to be stored locally when the app is first launched or when a site is first visited, allowing that site to work offline. There's a lot of actual interesting and fascinating stuff going on in there. There's also a lot of warts. For now, we're going to focus just on the core of the technology, which is providing a list of files to store. I've had a lot of experience implementing Appcache for the marketplace, some of which has not been great. I like to say I have a love-hate relationship with Appcache. Sometimes it drives me to tears, and sometimes it makes me supremely happy that I can make a web app that works whether or not the user has a connection. Another interesting thing about the Appcache is that it has a very special file format. It's not XML, it's not JSON, it's not HTML. It's a very special file, it has a special MIME type, and it begins with the words cache manifest. After that, you can put a comment, or anywhere in the document you can put a comment. Comments are useful in the cache manifest because the manifest will only trigger an update if it is changed. If you've updated the contents of all of your files but not their names, then you're actually going to need a comment to change the version number of the manifest, thus triggering a re-download. The other big section you're going to notice in a cache manifest is the cache section, of course. It contains a list of resources we would like the browser or the user agent to download when the cache is being updated. You can require local resources and do relative paths, or if you're pulling in external resources that you would like to be available offline, you may declare them using a fully qualified domain, and they'll still be fetched. One important thing to note with these resources must successfully fetch because the application cache updates monolithically. If any resource of these fails to load for any reason, the cache will not be populated because the user agent does not want to risk exposing a broken experience. It would rather expose none. This can be a little bit frustrating, especially as debugging these is not fully well tooled yet, meaning sometimes it's hard to tell what's wrong with your cache. But once you make sure all the requests are going through, you'll find that it's actually not too bad. Lastly, there's a network section. You can define specific URLs or a general class of URLs that should always go online whenever possible. You define this by making a network section. In this case, I'm saying all, because I'd like all of the resources that I have not explicitly named to go online. Next thing I'm going to talk about is deep linking and URL persistence. Like I said, URLs are a really important part of building an app that feels like the web and allows users to share your content. In the early days of these apps, the solution was to take advantage of the URL fragment. So even though your site technically only had one location and one path, we could store lots of information in what was used to represent what portion of the page you were looking at. They did this using the hash bang, meaning the hash sign and an exclamation point followed by a big old blob of data. This is kind of unfortunate because what this means is that when the user loads the app, first they're loading the base version of your app. It's important to know that the fragment is not sent to the server when a URL is requested, meaning that the fragment is kept on the client and is only given to the scripts that the server has provided. So first you have to download the entire app and start it up. And only once the app is started can you then look at the fragment and figure out what part of the app to load. Twitter famously did this with their tweets. So if you wanted to go look at a specific tweet on Twitter, you would enter the URL, it would download the entire homepage, and only after it had downloaded all of that content, it would then take you to the single tweet you wanted to see. This is very slow, very frustrating, and they've since fixed it. How did they fix it? They are now taking advantage of an HTML5 spec called the History Manipulation API. It exposes some methods for changing the browser's history and modifying the location bar without triggering a page load, and how to detect when the user has interacted with the history. So you can restore or preserve app state as the user clicks back and forward without having to completely reload your page. The two main pieces of this are the push state method, which allows you to define a new URL to show in the bar, a title of the page that you are putting in the bar, and a little piece of data that you could provide app state or any piece of metadata that you want to be associated with that particular visit. When you call that, the browser will update the bar, the data will get stored away for you, and you can forget about it. The next thing you can do is you need to listen for when the browser re-emits this piece of data. If the user hits the back button, the URL may cause the page to load a different URL. Or the browser may realize that you pushed that data in there and give it back to you via the pop state event. The pop state event will contain all of that nice state that you stored in there. So if you want to try to reconstitute your state back to an earlier state of the app, it's really easy. You can just put data away, and the browser will give it back to you, and you can use that data. The next thing I want to touch upon is how to detect touch support. There are sort of a lot of complicated or more advanced ways to do this that cover all the cases, but this is really the starting case. What we want to do is, this is actually the polyfill for detecting touch support in a web browser. It's not that much code, but it means that you have now a true or false variable that tells you whether or not that browser supports touch. Using this, you can do smart things. As opposed to saying $.click, you could say $.bind touch start. By doing this, that means that you are able to bind only the right events for the environment that you're in. What's important to note is that almost all web browsers trigger click events, even on mobile. Which means if a user touches a link with their finger, the click event will be fired. If it didn't, most websites wouldn't work. The hitch is, the browser wants to make sure that that user wasn't swiping or doing some other more advanced touch action, which means that they've put a delay on that click. So if you're only listening to click on mobile, you have to wait 300 milliseconds from the user time the user puts down their finger and lifts it before you know that it was a click. In your app, that's going to be slow and laggy, and the user's going to blame you. So if you're not listening for touch, you're giving your users an immediately more sluggish experience, which is not great at all. So really what we need to do is we need to go out there and take the lessons that we've learned, and we're going to take all this stuff and build super compelling applications that are using the latest standards, and we're going to build things that look mobile and feel native. And I hope that you help me. Thanks.